Earth, the third closest planet to the Sun in the solar system, is currently the only astronomical object known to have life and liquid water on it. According to radiometric dating and other information, 4.55 billion collections were formed more than a long time ago. Earth's gravity is surrounded by other objects in space, particularly the Sun and its only natural satellite, the Moon. Earth's orbit around the Sun takes 365,256 solar days, or 1 sidereal year. During this time, the Earth rotates 366,265 times around its circumference. Earth's axis of rotation is tilted relative to its orbital plane, and this tilt causes the seasons to occur. Gravitational interaction between the Earth and the Moon, it fixes the orientation on the Earth's axis, causing tides and gradually slowing its rotation. Earth, which gives its name to the group of Earth-like planets to which it is a member due to its solid or rock-weighted structure, is the largest member of this planet group by mass and volume, as well as the densest planet in the solar system. Earth's outermost layer, called the lithosphere, is composed of rigid tectonic plates that have been in motion for millions of years. While approximately 29% of the Earth's surface is land made up of continents and islands, the remaining 71%, which is covered with water, is called the hydrosphere, formed by oceans, lakes, streams, and other fresh waters. Today, most of the Earth's polar regions are covered with ice. The Earth's interior consists of the still active inner core of solid iron and nickel at the center, the liquid outer core that makes up the planet's magnetic field, and the mantle that causes the tectonic plates to move. Life that started in the oceans in the first few billion years of its history, by affecting the atmosphere and the Earth, led to the proliferation of anaerobic respiration creatures, and the emergence of aerobic respiration after the increase in oxygen levels. According to some geological evidence, life on Earth began about 4.1 billion years ago. Since then, the Earth's distance from the Sun, its physical properties, and its geological history have allowed living things to evolve and evolve. Throughout the history of life on Earth, biodiversity has increased over time, and mass extinctions have occurred from time to time. More than 99.9% of the species that have ever lived on the planet are extinct. There are separate estimates for the number of species still in existence today, while some species are not described. The survival of over 7.8 billion people living on Earth depends on the planet's biosphere and natural resources. Politically, there are over 200 independent states in the world. The constantly moving Earth has two kinds of motion. One of these movements happens around its own axis and is from west to east. It completes this rotation in 23 hours, 56 minutes, 4.09890369 seconds, 36. The second movement of the Earth with this rotation around its axis is around 7 minutes, creates the seasons and ensures the alternation of the seasons. The outer crust of the Earth and the layers of the atmosphere, air, and hydrosphere, oceans and seas, above this crust can be studied by direct observation. However, it is not possible to directly examine the structure of the Earth by reaching its inner parts. All the information regarding the internal structure of the Earth has been obtained from the study of earthquakes and from experiments on the materials thought to exist inside the Earth. Based on the presence of volcanoes and measurements of heat flux at the surface of the Earth's crust, we know that the Earth's interior is very hot. As you go deeper into the Earth's crust, the temperature of the rocks rises by 30 degrees Celsius per kilometer. Thus, the rocks located much higher than the lowest layers of the crust turn into red coal. In fact, the Earth's crust is very thin compared to the size of the Earth. If we think of the Earth as the size of a soccer ball, its crust is only the thickness of a postage stamp affixed to the ball. The remaining rocks beneath the crust reaches the incandescent temperature. Earthquakes are caused by the violent shaking of the Earth's crust back and forth as a result of the sudden movement of two large masses, plates, separated by a fracture in the Earth's crust, overlapping or moving away. In a major earthquake, some vibrations are focused in a circular field on the other side of the Earth. On the other hand, some vibrations do not go beyond the core. Thus, a ring-shaped shadow appears on the other side of the Earth, where no vibration is heard. The size of the core can be calculated by measuring the dimensions of the shade. In addition, by determining the propagation speed of earthquake vibrations, the density and therefore the composition of the materials they pass through can be determined. Laboratory experiments with molten rocks shed a great deal of light on these studies. The Earth's surface is covered by a layer of crust, the thickness of which varies between 6 and 70 kilometers. This layer, called the Earth's crust, sits on top of the very thick mantle layer, which consists of heavier materials and goes 2,865 kilometers deep. Where the mantle ends, the core begins, which stretches for 3,473 kilometers to the center of the Earth. According to geologists, the inner mantle layer pushed up the Earth's crust as a result of enormous upheavals and rose to the surface in many places. In addition, some rocks that are not normally found in the structure of the Earth's crust have reached the Earth's surface due to volcanic movements. Based on these data, geologists suggest that the upper parts of the mantle are made up of ultrabasic coral rocks. These ultrabasic rocks, located at the other end of the rock classification, where granite, which is described as acid rock, is located on one side, consists of heavy iron and magnesium silicates. It is thought that the lower parts of the mantle are of the same structure, but heavier and denser. The substances in the core are both heavier than those in the mantle and at least in liquid form in the outer part of the core. In contrast, the core is thought to be solid, like the mantle and crust. There is an extraordinary pressure in the Earth's core. Most of the known elements can be found very condensed under such great pressure, but the general opinion of geologists is that the core, like some ferrous meteorites, is composed of metals nickel and iron. Place is derived from the Old Turkic word yer, which means earth, world, ground. The earliest usage of the word is recorded in the phrase when the root terra was created in the century, when the blue sky was created on top and the black earth on the bottom, in the Orkhon inscriptions dated to the 8th century. The first written use of the word earth is mentioned in Asik Pasha's Garibname work in 1330. Earth is another word that means earth. The word derives from the Arabic word ar, which can mean earth, country, or expanse. World and world are words of Arabic origin and the other of Iranian origin, and can be used to describe both the Earth and the universe. The oldest material found in the solar system is 4.5672 plus or minus 0.0006 billion years ago. 34. The formation of the primitive Earth began 4.54 plus or minus 0.04 billion years ago. 35. The Sun was formed and evolved with the structures in the solar system. In theory, the source of the molecular nebula, which forms the structures in the solar system, including the Sun, Earth, and other planets, when considering the complex compound structures and the elements it contains, was formed by the dispersed remnants of a young type star that had already completed its life and the interstellar matter rotating around a center and gradually condensed. Hydrogen and helium molecules concentrated in the center began to form a new G2 type star, namely the Sun, and planets began to form in dense regions in the surrounding disks. Earth, on the other hand, is a terrestrial inner planet third closest to the Sun. During or after the formation disks, these terrestrial planets were the scene of heavy meteorite collisions. Frozen ice, silicate and metal structures in the structure of meteorites provided the formation of lands and oceans, and heavy iron and nickel elements concentrated in the center formed the core of the planet. The heavy meteorite bombardment has waned as the asteroid belt becomes more stable as a result of Jupiter's strong gravitational influence. Living life, which started to form and evolve when suitable conditions were created 3.5 billion years ago, and then, especially with the landing of plants, due to the photosynthesis they have made since 500 Ma. See the evolution of plants since 500 Ma. The structural composition of the atmosphere changed significantly and caused the oxygen ratio to increase. The age of the Earth cannot be measured directly by the age of the rocks, because even the oldest known rocks were formed from older rocks that no longer exist on Earth today. The oldest rocks ever identified were found in western Greenland and are 4.1 billion years old. The best method available today to calculate the age of the Earth is the conversion of radioactive elements into other elements as a result of their halving. For example, the radioactive element uranium has two different types of atoms, isotopes, such as uranium-238 and uranium-235. Both of these atoms turn into lead atoms in a very slow process. With the transformation of uranium-238, which is slightly heavier than the other uranium isotope, a lighter isotope of lead, Lead-206, is formed, and with the transformation of uranium-234, a slightly heavier isotope, Lead-207. The rate of conversion of